everyone. I am going to explain a sample problem from our Hess's Law practice problem number 3. It says calculate the delta H for the reaction 2S plus 3O2 to form 2SO3. From the given reaction S plus O2 to form SO2 with the delta H negative 297 kilojoules. And then number 2, we have 2SO3 to form 2SO2 plus O2 with the delta H 198 kilojoules. And so now we are going to figure out from the two given equations, we want to figure out this desired. This is our desired equation. In other words, we are going to manipulate the two given equations for us to be able to find this. And we want to find the delta H based from the delta H's given here. So now first, number 1, if we notice we have S and O2 is in the reactant, they are in the reactant side, and also same here with our desired equation. So in other words, this is already a hint that we have to keep equation 1 as it is, because we wanted the S and O2 to be on the reactant side. However, if you notice, in our desired equation, the S has a 2. It says 2 moles of sulfur. But over here, we only have S. So this is also another hint that we have to multiply the entire equation by 2. Now take note, if you multiply the entire equation by 2, you have to multiply the delta H as well. Okay? So that would be our step number 1. Now, what are we going to do with the second equation? If you notice, the second equation starts with a sulfur trioxide, which is in the reactant side. But if you look at the desired equation, it is in the opposite side, which is the product side. So now that alone is already giving us a hint that we have to flip the equation. So then this SO3 will be the same as the desired equation, which is actually found in the product side. So again, number 1, we have to multiply the equation by 2, keep it as it is. We also have to multiply the delta H by 2. Equation 2, we have to flip it, and you also notice that 2SO3 is already 2SO3, so we really don't have to do a thing except for flipping it. Now when you flip it, always remember that the delta H sign will change. So if the original in this case is 198, after you flip the equation, it will become negative 198. So let's take a look at what does it look like now. So over here, here's our solution. We have, as what we said earlier, equation 1, we have to multiply it by 2. So multiplying it by 2 will give us 2S, and then 2O2 to form 2SO2. As well as our delta H, which is now negative 297 times 2 would give us a negative 594 kilojoules. On the other hand, equation number 2, we said we have to flip it. So we flip it. So now that 2SO2 from here is in the reactant side, and the plus O2 to form 2SO3. 2SO3 now is on the product side. So we just simply flip it. And because we flip it, we change the sign to negative 198 from the original, which is positive. So now when we're done, we can then figure out the desired equation, which is this one from the original one over here. Okay, so what are we going to do? Before we come up with the desired equation, we have to first, in our solution, we have to first cancel the ones that are the same, one on the reactant and one on the product side. So for example, let's take a look. Oh, we have here 2SO2 is in the reactant side, and then 2SO2 right here is in the product side. This has to be canceled. Okay, so we will cancel that one. Let's take a look. We will cancel 2SO2 here, and then this one. And I think that's about it. There's no more that are the same on both sides. So then we can just bring down the ones left, 2s. O2 and 2O2 and O2 are on the same side, so we just simply add it. So that would be 3O2 to form 2SO3. What are we going to do with the delta H's? You simply add the two delta H's. So we have negative 594 kilojoules plus negative 198 kilojoules would be equal to negative 792 kilojoules. So we were able to answer what is asked in the problem. So we were able to come up with the desired equation, and we calculated the delta H for that equation. I hope this help you understand this sample problem.